Okay, this is our first day of triangle proofs. If I could say one thing before we start triangle proofs, it would just be like nobody is great at these, and they take a lot of effort and a little bit of struggle. So don't get too frustrated if you don't get it in the first 2 minutes. Like, you might have to think about it a little longer than that, and that's usually what frustrates kids, is that there's not a formula to plug in. There's not a straightforward way to do this. So we're going to keep going like we have been with our triangles. We want to be able to look at them and go, I think these are going to be equal or congruent, and then we got to pick out our way. And our job now is just we're going to be responsible for naming more of the parts before we can just jump to it. So in previous lessons, I would have just shown you these two. We would have said, yep, shared side, and then we would have just said they're equal by side, side, side. And so now your job is going to be to state the things that you start with, state the things that you add, and then say your triangles are congruent. So you're going to have just a couple more steps to take care of. So first on your theorem card, I just want to fill in a couple things for you. We've already talked about the 4 types of angles, and if you get parallel lines, I'm not sure why I put a separate box there, but if you get parallel lines, you will definitely be talking about these 4. And again, your number 1 choice is the alternate interior angle. We're going to use that most of the time. Some other words that might come up in proofs, one is definition of a midpoint, or if you say that you have a midpoint, what it means is then you've got a segment that's equal to another segment. So a midpoint cuts a segment in half, and if you have a midpoint when you have your segment, then there's got to be two pieces that are now equal to each other. Same thing with a bisector, although bisectors can happen for angles and segments. So you could have an angle equals an angle, and you could also have a segment equals a segment as a result. So if you ever see the word bisector, you can have that happen to both an angle and a segment. So if we had an angle and we bisected it, then these 2 angles would be equal. Definition of a right angle, this is going to tell you that something is a right angle. So usually you're saying that there's an angle that's a 90. Sometimes maybe you get one of the 90-degree angles, and so you need to say that the other one is. That's where we'd probably use that. Definition of a right triangle, it's really to establish or to kind of be the base of HL, not of, establish HL. So if you're looking to talk about hypotenuse leg, you need to have a right triangle. So sometimes you'll just start off by saying definition of a right triangle. We have talked about vertical angles before, and then definition of perpendicular lines. It means I have 2 lines coming together to make 90. So there must be some angles that equal 90 degrees that you can then talk about. Segment addition postulate, that was our part plus part equals whole thing. So there must be 2 pieces we're going to talk about that equal up to the whole thing. Substitution property, just like any sports event that you have, if you take a player out and put one in, that's called substitution. So we're just taking a value out and replacing. Whoops, replacing. So you're just taking something out and put something else in its place. That's substitution. Transitive is kind of an interesting idea, and usually these 2 can be used interchangeably. Transitive is just a little extra quirky if you were ever trying to prove essentially 3 things equal. So let's say I am the same height as Mr. Summers. Mr. Summers is the same height as Mr. Just. Then that means I could say I am the same height as Mr. Just. You can kind of cut Summers out of the middle. So transitive property is how you can kind of make a trail for 3 things being equal in an effort to kind of get rid of the middle part and have your 2 outside pieces equal to each other. It comes in handy when we've got different types of angles equaling 180, and then since they both equal 180, they can equal each other. So it does come in handy every once in a while, but these 2, they're very closely linked. But for right now, we'll probably be leaning heavily on substitution. We'll get into transitive in a couple days. Reflexive property, we've talked about that already. Something is equal to itself. That is usually a shared side is when we're talking about that. Okay, and then we've got our 4 types of angles, and now we're going to try our first proof. So first proof says that KL and LN are congruent, and the first step in any proof is just the given. So you just get to copy that down, which is not anything for you to figure out. You just have to copy. And the reason is given, and we did the exact same thing when we were doing algebra proofs in 2.7. In order to start a problem, you kind of have to start with some information, and then you work through that information to say what else will happen. So in our picture, remember, we're always checking for vertical angles and shared sides, and we happen to have a shared side this time. Our third thing to check for is parallel lines, and we'll hit one of those today too. So I don't have any vertical angles, but I do have a shared side, and that's right up the middle. So I'm going to say that LM is congruent to LM. That is reflexive property. And I'm going to mark it just so I can see that it is congruent to itself. And then as part of this triangle, now I can see that this is a side-side-side triangle. So these triangles are congruent. The last step is always what you're trying to prove. So KLM, whoops, stick an L in there, is congruent to triangle NLM. And that's your first geometry proof. So for this next one, we're talking about, actually we're going to have some parallel lines in this one. So first I got BC equals DA, so I've got a BC here with DA. And then they also said that BC is parallel to AD. If you didn't remember those two vertical lines, they mean parallel. And the reason I can put all that stuff there is because it is given. And they already did the tick mark, so that's kind of nice. And then they did the triangles for parallel, so I've got those. Always looking for these three things again. So I don't have vertical angles, but I do have a shared side. So that AC in the middle, and this will mess with your head a little bit, but it's going to be CA. So when you have a side in the middle, if it looks like a butterfly, like it's perfectly folded on both halves, then you can repeat the letters. This one, if I were to fold this D would kind of end up right about here, and B would end up right about here. They wouldn't fold to each other on that line. So since it's not quite a butterfly effect, I need to switch the letters. Still reflexive property, which is, again, it's kind of weird when you're saying something's equal to itself, but I switched the letters around. But we're going with reflexive property. So now I've got this. I'll put 2 tick marks on there. So out of the 5 things I have, I've got 2 sides already. It's definitely not HL. If I was narrowing some down, I could definitely cross off HL. And then the ones with the 2 angles. So if I had side, 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 angle, side, angle, side, angle, side, HL, and AAS. I've already got 2 sides, so that kind of kicks that one out. I don't have a 90, and I get rid of that one. So I've got 2 left. I can't just mark this side because I want it to be. If I don't have any reason why those are equal, I can't just add marks to them. But I do know that the lines are parallel. I haven't discussed that yet. And I'm just going to extend it a little bit. Seems to help kids when we extend to those parallel lines and then the transversal. And then if you can see that these are the alternate interior angles. So since I had parallel lines, I knew I was going to talk about one of those 4 types of angles, and then I've got that alternate interior right there. So alternate interior angles congruent theorem, and then we just need to name them. So I'm going to say BCA. And make sure that where that arc mark is, that letter, that's the middle of your 3. So where my arc mark is, that letter A has to be in the middle. So I'm going to say DAC. Looks good. And now I'm just going to copy down my proof. So triangle ABC is congruent to triangle CDA. They gave me that, so that's just what I copy there. And then my triangles are equal because of, definitely not side, side, side. I named an angle, so it's got to be side, angle, side. One more on the proofs notes today, and then you have a worksheet that's got a few of them on there. RS to VU, so that's just my given. And then I've got angle S and angle U. And then they already marked that, so I've already got the tick marks there. I've got the arc mark for that guy. And remember those 3 things we're always checking. So vertical angles, I have those this time, which are right there. So I'm going to say RTS is congruent to VTU. And I went R, the angle that had nothing on it, to the middle and then back out. So I have to start at V, which had nothing on it, head to the middle, and then back out. Oh, this is given. And the reason I know these 2 are equal is because of vertical angles. And my last statement is always whatever I'm trying to prove. So we'll throw that in there. And then out of my 5 reasons, sorry, let me copy them real quick. I have definitely not side, side, side. I have 2 angles in a side, so it can't be that one. I don't have a 90. So it's one of these 2. My side is only touching one of my angles, so I can only have the one where the S is touching one of the A's, not both. So this is AAS. That's your first day of proofs. When you get to your homework today, you're going to have a couple of different words that you haven't seen before. You're going to have a one with a midpoint. And remember from the blue card, that means that you should be able to say that some segment is equal to another segment. And you're going to have one with a bisector. And I think that's an angle one. So you're going to have some angles that are equal. And your job today is to just kind of to use the given and then see what else they gave you for information so that you can prove that those two triangles are congruent.